For decades, software engineering relied on relational databases. These systems enforce strict rules by mapping data across structured tables. But maintaining those relationships requires significant CPU overhead. Every time the system links tables through complex joins, it consumes processing power to validate the connections. When a modern web application handles millions of requests per second, that overhead creates crippling latency. Organizations often try to scale vertically, adding more expensive hardware to a single server, but eventually they hit a hard physical wall. Traditional databases collapse at this scale, precisely because they attempt to perform too much validation and cross-referencing for every single transaction. Surviving this traffic required a radical engineering pivot. Developers asked a counterintuitive question: what if we build a database that does almost nothing? The result is the key value store, the simplest and most stripped-down subclass of NoSQL databases. This technology abandons strict relational features, employing ruthless subtraction to achieve one prize: absolute speed. The architecture operates like a massive distributed hash table. It restricts the entire programming interface to just 3 basic commands. Every piece of information is assigned a key. This serves as a unique locator to instantly retrieve data from within the massive grid. The database engine interacts with this value as a completely opaque blob. In this context, opaque means the database does not index any internal properties. It does not look inside, and it doesn't care if the payload is a short text string, a nested JSON document, or a serialized photograph. By remaining intentionally blind to the contents of the data, the database eliminates the processing friction of internal inspection and strict validation. This chart shows the mathematical result of that subtraction. As data volume on the x-axis increases, retrieval times for traditional databases curve upward. The key value stored, however, achieves 0.1 constant time complexity, maintaining a perfectly flat line. Constant time complexity means fetching a record takes the exact same microsecond, whether the database holds 10 items or 10 billion items. That efficiency yields a second advantage: massive horizontal scalability, a capability used by platforms like Amazon DynamoDB and Riak. Because the data pairs are standalone and share no relational links, the hash table can be partitioned and distributed across thousands of separate commodity servers. This speed makes these databases the standard for in-memory caching layers. Tools like Redis are specifically deployed to temporarily hold high-demand data and absorb sudden traffic spikes. By handling those high-velocity requests, these systems absorb the brute force impact of traffic surges that would otherwise crush a traditional database. However, the laws of computer science are rigid. You cannot cheat them. You can only trade one computational burden for another. The first major sacrifice is the total loss of complex querying and filtering. If you want to find a specific attribute hidden inside those values, you cannot query it directly. Without indexes, you are forced to slowly scan the entire database, item by item. The second sacrifice is the complete lack of schema enforcement. Because it accepts any payload, the burden of data validation shifts entirely onto the application code. There are also physical limitations. Caching tools like Redis operate directly in memory for speed, meaning total storage capacity is strictly bounded by the amount of available and expensive system RAM. In exchange for database speed, developers must ensure data integrity, manually map complex relationships, and completely organize the system. Key value stores serve as specialized instruments deployed in tandem with relational databases for high-velocity traffic. Ultimately, web-scale performance and absolute uncompromising speed are achieved by stripping a system down to its absolute bare essentials.